Hello, welcome to the channel. The problem of today is from definite integration, and the problem is as evaluate the integral from 0 to infinite x minus 1 upon a square root of 2x minus 1 and log of 2x minus 1 dx. Let's see the solution. Here is our problem. Let this is as I. For solving this integration, put u equal 2 to the power x minus 1 substitution, and du becomes 2 to the power x ln 2 dx, and from here the dx can be evaluated as du upon 2 to the power x ln 2, and the value of 2 to the power x in term of u is u plus 1 ln 2, and as from 0 to infinite the limit will remain as in form of 0 to infinite, because at x equals 0 u becomes 0, and at infinite this also becomes at infinite. The upper limit will become infinite. That the limit will remain the same. Now for finding numerator as x, 2 to the power x can be written as u plus 1. Taking ln on both sides, we get x ln 2 equal ln u plus 1, and x equal ln u plus 1 upon ln 2, and for x minus 1 this becomes ln u plus 1 minus ln 2 upon ln. This is all our transformation from x to u. Now the integral becomes I equal integration 0 to infinite and x minus 1 as ln u plus 1 ln u plus 1 minus ln 2 upon ln 2, and in denominator as 2 to the power x minus 1 can be written as a square root of u, and this becomes ln u, and dx as du upon u plus 1 ln 2, du upon u plus 1 into ln 2, that is 1 upon ln 2 whole square can be taken out from the integral sign, and this becomes ln u plus 1 minus ln 2 upon a square root of u ln u and u plus 1 into d. Now for making it simpler, substitute u equal t square. Also in this case the limit will be same as from 0 to infinite, and we get du equal 2t dt, and by substituting this we can get the simpler form of a square root of u, and it can be written as 1 upon ln 2 whole square 0 to infinite plus 1 minus ln 2 upon a square root of u become t, ln t square and 1 plus t square. The value of t to t becomes cancelled, and 2 can be taken outside from the integral sign, and this can be written as 2 ln 2 whole square. This becomes 0 to infinite ln t square plus 1 minus ln 2 upon ln t square into 1 plus t square dt. Now in next step, from 0 to infinite, for making it finite, 1 plus t square, you can write it as I equal 2 upon ln 2 whole square, just breaking it from 0 to 1, ln t square plus 1 minus ln 2 upon 1 plus t square ln t square dt plus 1 to infinite ln 1 plus t square minus ln 2 upon 1 plus t square ln t square dt. So this is as I1 and this is as I2. We have broken it in two integrals to make it finite. If putting t equals z in I1, we get dt equal dz, and by using this, the limit will remain the same. And in I2, putting t equal 1 by z, and the dt becomes minus 1 by z square, and limit will be at t equal 1 at t equal 1, z will be 1, and t equal infinite, the z will be 0. Now the integration will take the form in I1 and I2. You can get I as twice upon ln 2 whole square, and 0 to 1, the first integral becomes t equals z, that is ln 1 plus z square minus ln 2 upon 1 plus z square ln z square dz, plus at 1 this becomes 1, and at infinite this becomes 0, and ln 1 plus 1 upon z square minus ln 2 upon 1 plus 1 upon z square ln 1 upon z square, and dt is minus 1 upon z square dz. Simplifying this, 2 upon ln2 whole square, and integration 0 to 1 ln 1 plus z square minus ln2 upon 1 plus z square ln z square dz plus 0 to 1. This becomes ln z square plus 1 by z square by z square minus ln2 upon z square plus 1 by z square, and minus ln z square minus 1 upon z square of b. This z square becomes cancelled, and from this minus minus it becomes plus. Now it becomes ln 2 whole square 0 to 1 ln 1 plus z square minus ln 2 upon 1 plus z square ln z square. Now reversing the limit, we get minus sign from 0, sorry, this is 1 to 0, this is 1 to 0. Reversing this, we get 0 to 1, and this becomes ln 1 plus z square minus ln z square minus ln 2 upon 1 plus z square and ln z square dz. Now since the limit of both the integration is same, now combine these two, we get integration 0 to 1, the denominator is same, ln 1 plus z square becomes cancelled, as well as ln 2 becomes cancelled, and this becomes minus minus plus, and this becomes ln z square upon 1 plus z square, and this is ln z square dz, and this becomes cancelled, and this is our tan inverse z, that is 2 upon ln 2 whole square, and this gives tan inverse z from 0 to 1. At tan inverse 1, this becomes pi by 4, and 2 upon ln 2 whole square into pi by 4, that is, this becomes pi by 2 into 1 upon ln 2 whole square. That is, the final answer of the given question is equal, I equal pi by 2 into 1 upon ln 2 whole square, or this can be also written as pi by 2 ln 2 to the power minus 2. This is the required answer of the given question, and this is the final solution of the given question. And The result of this is pi upon 2 ln 2 to the power minus. And hope you will understood it well and enjoy with the solution. Thank you.